All right, hey folks, we are doing chapter 7. So we have 2 more chapters basically. We have anyway, we're continuing with our geometry kind of focus. We're going to be talking about the Pythagorean theorem. I really should have just copied that. Pythagorean theorem. This was created by a Greek dude named Pythagoras a long time ago. Let's see here. Let's see if we can figure this out. No, what am I doing here? There we go. Let's see. Pythagoras. When did he live? Yeah, Pythagoras. Let's see. Yeah, Greek dude. Pythagoras of Samos. Let's go to Wikipedia. He's a philosopher and a mathematician. Yeah. 570 to 495 BC, right there. Kaboom, right there. Yeah, so he loved triangles. So he made up this, not made up, but he discovered this theorem about right triangles, where the idea is that you have this side here, you have this side here, and you have this side here, right? If you take this side and you kind of make a square on it with the same side length, right? And you do the same thing here, and you do the same thing here, right? If you take the area here and the area here of those two squares and you add them up, you'll match the area over here. And that's kind of the idea with it, right? So now we have a couple vocabulary words that are unique to right triangles here. Well, one really. We have the hypotenuse and then we have the legs, right? The hypotenuse, right, is right here. Okay, it's the side across from the right angle. Okay, so I have this right angle right here, okay, and you can always find the hypotenuse by just drawing an arrow away from it, okay, and that's right there. We label that side C, okay, and then our legs, technically there's 2 of them, right? We have here and here, we have A and B, and these are just the sides next to the right triangle. Sorry, the right angle, my bad. So if a triangle has a right angle, it is called a right triangle. Just so you know. So these are all dealing with right. These are all dealing with right triangles, or discovering if they are right triangles or not. Okay. So we have the hypotenuse right here, and then we have a leg here, and we have a leg here. So yeah, that's that. Yeah, that's the definition right there. So the actual formula is right here. It's a squared plus b squared and equals c squared. So basically, again, you take this, you make a square. You take this, you make a square. You add them together, and it's equal to the square of this, right? When I talk about the square, I'm talking about the area of that square, right? How big that square is, right? So right triangle has side lengths 15 centimeters, 25 centimeters, and 20 centimeters. Can you use the Pythagorean theorem to write an equation that describes how the side lengths are related? Well, one other thing that I actually forgot to mention, right? The hypotenuse is the longest side. That is important. Okay, you can see that this right here is clearly longer than either this one or this one, right? We can get a ruler out to actually measure this. We'll double check that, right? Prove I'm not lying here, right? We have right here, this is just about 7.5 centimeters, okay? This one is under 7 centimeters, and this one is just about 3 centimeters. So clearly, this is the longest side, and it's always going to be the longest side, okay? So if we have these 3 sides, we have 15, 25, and 20. Well, 25 is clearly the longest. So I'll go right there, okay? And since I have 3 colors, might as well use them. 15, I like to put the shortest side in A, and kind of the middle side in B. Technically, it doesn't matter, but I like to be consistent about that, because you could put the 20 here, and you could put the 15 here if you wanted to. It doesn't really matter, but just to be consistent, I like to make my short side the A right there. And so now what we do is we square these. We make a square, right? Figure out the area of the square. Let me get a calculator here. I was let's use my handy dandy Desmos calculator, and I'll take 15 right there, and then I will square it, and I get 225. Be consistent with my colors here. Okay, and then we'll take 20 squared, and we get 400. And then we'll take 25 squared, and we end up getting 625. Okay, now if these two add up to that, which that they do, 225 plus 400, let's double check that. That does give us 625. Okay, so 625 equals 625. That's how you kind of plug these numbers into that formula, right? You take your shortest side, put it in A, your middle side, put it in B. Again, it doesn't really matter. You can flip them if you want to, but I like making the A side the short side. And you take your long side and put it in the C value. And kind of that's how you put it together. So we basically just proved that if you had a triangle with these three side lengths, it is a right triangle, right? So if it works out, it is a right triangle. If it does not work out, it is not a right triangle. That's kind of the idea here, okay? Okay, so of course we'll have missing variables that we have to find, right? So I'm actually going to call this x right here, okay? So what is the length of the hypotenuse of the right triangle? We know it's the hypotenuse because it's across from the right angle, okay? We just draw that arrow to double check, okay? Now, I'm going to call this A. It's my short side. I'll call this B. That's my long side. And this, we could call this C or X. It doesn't particularly matter. But yeah, now we take this, right? We take A. And remember, it's A squared plus B squared equals C squared. Okay, so we take 8. We square it. We add it to 15. Square that. And then, yeah, shoot, what am I doing here? Let's just call that C. Okay. And it's equal to C squared. Okay, so 8 squared is 64, because I just know off the top of my head. Let's see, clear everything else out here. So 8 squared is 64. 15 squared is going to give us, I think, 225, yeah, because we did that in the previous one. And then let's figure it out. Let's add 225. We'll add 64, and we get 289. Okay. Oh, sorry, I don't want to do that. Equals C squared. I want to set it up like this. This is an equation after all, right? So equals C squared, okay? Now what we're going to do, since we have this squared, we have to get rid of it on that side, so we'll square root that side. So we'll take 289, clear that out, square root, and we just take the square root of 289, which is going to give us 17. So the length of that is 17 centimeters, right? So that's it right there. That's our answer. We found the length. And you can double check this. If it's longer than either of the other two when you're finding the hypotenuse, then, it makes sense. It's logical that that's what your answer is going to be, okay? So that's one kind of problem you're going to see, right? The other kind of problem, I guess, there's when you're searching for missing sides, right? You'll either find a missing hypotenuse or you'll find a missing leg, okay? So Mara is repairing the trim on one side of a display case sketched. Did I copy that correctly? That doesn't make sense. She has a piece of trim that is 20 inches long, so right here. Does Mara have enough trim to repair the display case, right? So let's do this again. We'll have this as our C value because it's across from the right angle, right? I wish I had colors to match this. This is 20. It doesn't really matter. We'll call this the one we're searching for A, and we'll call the one we have over here B, right? So we have A, which we're searching for, we have B, which is 20, and we have C, which is 29. So when we plug this in, it's going to be A squared plus 20 squared equals 29 squared. And we'll just use our calculator for this stuff, right? That's why we have it, right? 20 squared is going to give us 400. So A squared plus 400 plus 400. And I'm just going to rewrite that. A squared plus 400. Okay, and then we take 29, clear that out, 29, and we square it right there. We get 841 right there. Okay, now this is where, because up until this now, it's been kind of the same, right? But what we got to do now is we got to subtract this 400, whereas we added in the previous problems, right? So there's two kind of problems here, right? When you're looking for a hypotenuse, you add and then square it. Okay. When you're looking for a leg, you subtract and then square root it. All right. So that gives us a squared equals 441. Okay. Because 841 minus 400. Okay. And then we'll just take the square root of 441, and that gives us 21. So A equals 21, and that's inches. So yeah, so that gives us that side right there. Okay. All right. Now, another kind of problem you can have is you can just test right triangles, okay? So, again, our equation is a squared plus b squared equals c squared, okay? Okay, cool. So we've got triangle A right here. We have our shortest side is A. Sorry, A is 6, 9.1 is B, and then 10.8 is C, because that's the longest side, right? So we'll just kind of do it like this, okay? We'll have it broke it down. All right, so then we go 6 squared plus 9.1 squared equals 10.8 squared, like that. Okay. All right, so 6 squared is going to give us 36. I know that off the top of my head, so I don't need to worry about it. Now 9.1, since it's decimal, I'm going to put this in here. That gives us 82.81. Okay, and then we'll jump down and say 10.8 squared. That gives us 116.64. I can already tell this isn't going to work out. Okay, so now we add these two together. So we take 82.81, and we add 36, and we end up 118.81. And we can see that they do not equal each other. Okay, so not a right triangle. Okay. I'm going to show you a very easy way to do this in the calculator as well. So let's see, but I'm going to do it kind of the same way. We've got A, we've got B, and we've got C. Okay, so that's 2 squared plus 9.9 squared equals 10.1 squared. Okay, now clear all this out, and then I'm going to show you just a super simple way to put this in your calculator, right? So 2 squared plus 9.9 squared, that's 102.01, and then we'll just go down to the next one. We'll say 10.1 squared is 102.01, right? So we add those two, we square them, we add them together, equals that, and we square that one, we get that. So we end up with 102.01 is equal to 102.01. So yes, it's a right triangle. Okay. And this is why I like the Desmos calculator, because it allows you to do things like that. It allows you to keep your previous answers and kind of go back and see them in that line right there. Because you could have, I mean, right, you could have like a lot of different ones right here where you can see them. So anyway, so yeah, and this is just summarizes it right here. The Pythagorean theorem is an equation that relates the side lengths of a right triangle, a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So just right there. Now, I think I'm going to have to adjust my notebook because I'm running out of table of contents space because I think one of my table of contents pages got torn out. But yeah, I'll fold this and put it in there.